welcome to Kuwait and to your new endeavor. Okay. Hmm. Okay. Next one.
Hi, sir. Myself, Nasif. I'm from Kerala, Kannur.
Kannur. Okay. Welcome to Kuwait. Okay. Hmm.
Hi, sir. I am Aravind. I am coming from Kottayam.
What time? Okay. Welcome. Your photo is not coming. Only I think. Yeah. Now it's okay. Okay. You are from Kottayam, huh?
I am from Kottayam.
Okay. So next one. Now how many? 5, 6 finished, I think. 5 finished. Okay.
I am Sharaf, coming from Malappuram.
Malappuram. Okay. Welcome to Kuwait. Okay.
Hi sir, I am Faiz. I am come from Malappuram.
Malappuram. Okay. Welcome. Okay.
Thank you.
Okay. All
Hi,
finished?
sir. Hi, sir. I am Ajin Joseph, coming from Kottayam.
Kottayam. Okay. Welcome. Okay. So all have been introduced. Huh? Okay.
Yes,
So
sir.
let us start a brief outline of the power plant, how it is running. I think most of you people may be knowing, I don't know, but how the power plant runs, especially in Gulf countries. In India and all, power plant runs with coal because our fuel is coal because we don't have oil. So in Gulf countries, oil is cheap, so they use oil, that is heavy fuel oil, to fire the boiler. So this boiler will use heavy fuel oil for boiling the water. Inside the tube, there will be water, and outside the furnace, it is oil. So they will fire the oil, and this steam water inside gets heated up to 500 degree temperature. So 550, 505, like that, the temperature. But how this temperature increases to 500? Normally water boils at 100 degree, no? So how the temperature goes to 500? Because the increased pressure of water. When the pressure increases, the boiling point increases. Whereas in the vacuum, it is reducing. So inside the boiler, the pressure of water will be around 150 to 170 bar pressure. So the water boils at 500 degree and the superheated steam will be 500 degree temperature. This 500 degrees temperature steam is transferred to turbine at high pressure. The turbine rotates, and the turbine rotates and it is connected to the generator, and the generator produces electricity. So this is the main outline for this boiler. So normally in Gulf countries, there is a shortage of water. So water, normally boiler, high pressure boiler needs purest form of water. Purest form of water. Everybody can hear or no?
Yes, sir.
Okay.
Yes, sir.
So inside the boiler for treatment, we need highest quality of water. So normally highest quality of water in Gulf countries you will not get, because normally it is seawater. So what they do is the seawater is converted to distillate water by distillation plants. That is called seawater distillation plant. So seawater, the salinity of seawater, salinity normally in chemical terms we use conductivity. Conductivity, everybody knows conductivity or no? What is conductivity? Conductivity, actually normally you know resistance, ohms. Ohms is the resistance of an what you call an element. So when current passes through that ohm, it provides some resistance for the flow of current. Whereas in the water, it is support the flow of current. So that is called inverse of resistance, and it is called conductivity. So normally the conductivity is measured in microsiemens. microsiemens per centimeter. So when somebody you will also want can write down. This is very important in your caliber in your their job and all, because conductivity is everywhere. You have to see the conductivity. Conductivity is called the measure of dissolved solids. How much dissolved solids inside the water? The conductivity increases means the number of dissolved solids, the quantity of dissolved solids is more. Suppose in seawater conductivity in Kuwait, it is 65,000. That defines 65,000 millisiemens per ohms, per centimeter. So it is called 65 millisiemens. The microsiemens will be converted to millisiemens, 1,000. So 65,000 millisiemens is equal to 65,000. 65,000 microsiemens is equal to 65 millisiemens. So the conductivity of seawater in Kuwait area, especially Shuaik, Sobia and all area, will be around 60 to 65,000 microsiemens. So this water is used in distillate water, in distillation plants, and this water is boiled. This water is boiled at normally water boils at 100 degree temperature, no? So inside the distillation plant, there is vacuum. They create vacuum mechanically by using steam. That is separate thing you don't need to study. You can understand when you work there. So this water, the distillation is under vacuum inside distillation. Inside distillation plant, the seawater is distilled, boiled, and the evaporated water is condensed to get distillate. So the 65,000 microsiemens water is boiled and the steam is condensed to get pure distillate water. So 65,000 millisiemens microsiemens will be when boiled we get around 10 to 15 microsiemens water. So that is called distillate. This distillate is produced in every Gulf countries. So they use this distillation under vacuum. This is the main thing. So in distillation plant, there are 23 stages. So that you can learn afterwards. But this seawater is passed through distillation plant and it is boiled using steam. And this evaporated condensate is taken as distillate. And so the conductivity of seawater from 65,000, we get to 10, 15 microsiemens. This called pure distillate water. This distillate water still contains many minerals. Some minerals, not many, so some minerals. So this we cannot use inside high pressure boiler. So high pressure boiler, we need pure water. So if there are any contaminants inside water, when it passes through boiler, it forms scales inside the tubes, and this scale inside the tubes will obstruct the flow of steam or water, so that the tube will rupture in due course. So we need to prevent the formation of the scale inside the tubes, boiler tubes. So we need pure form of water. So this 10 to 15 microsiemens distillate is again purified using water treatment plant. So water treatment plant has 3 ion exchanges. Ion exchange. So the conductivity of water treatment plant input is 15 microsiemens. I told you from distillation we get 15 microsiemens. This microsiemens is passed through 3 stages of water treatment plant: cation, anion, and mixed bed. Cation normally removes all the metallic parts, suppose calcium, magnesium, because the scale forming material inside the water is calcium, magnesium, to some extent sodium, these things. So this calcium and magnesium should be totally removed before feeding to the boiler. So we need purest form of water inside boiler, because I told you, if any minerals are there, calcium will form calcium carbonate inside the tube. Magnesium will form magnesium carbonate, magnesium bicarbonate inside the tube, and it will reduce the diameter of the tube, and it will reduce the flow of steam or water. And eventually what happens, the boiler tube will explode because of high pressure. So this distillate water is passed through cation, anion, and mixed bed in water treatment plant. Cation normally removes calcium and magnesium, all metallic parts as cations. Cations are positively charged ions. That's like calcium is positively charged, magnesium is positively charged, sodium is positively charged. All these minerals, silica is normally removed in the anion. So this from cation, it comes to anion. Anion removes silica. So then it will come to mixed bed, half cation and half anion. This is actually called polishing. This mixed bed function is polishing. So remove any leftover cations or anions from the cation, anion, whatever is there, it is removed in the mixed bed. So mixed bed acts as a polisher. So the input water conductivity to water treatment plant, I told you from distillation, it is 10 to 15 microsiemens. And when it comes out of the water treatment plant, the conductivity comes down to 0.5 microsiemens. That means less than 1. Normally, purest, chemically we tell purest form of water conductivity is 1. So, but still it will have calcium, magnesium, and some minerals. So it will be further removed to make the conductivity 0.5 microsiemens. That is the purest form of water. The purest form of water, 0.5 microsiemens, it's not a conductor of electricity. It will not conduct because it doesn't contain any minerals inside. So this water, 0.5 microsiemens water, conductivity water, is used inside the boiler to produce steam. So actually what happens, the water treatment plant output conductivity is 0.5 microsiemens, but its pH will be 6.1, 6.2, 5.9 like this. So theoretically, if the pH is less than 7, it is called acidic. Everybody knows it, no? You are all graduates, so less than 0.7 pH is theoretically acidic. So this water treatment plant output pH is 5.9, 6.1, 6.2 like this. So, and the conductivity is 0.5 microsiemens. So this water, if you feed inside the boiler, it is acidic. So it will remove the iron, what you call erosion inside the tubes. So what we will do, we will increase the pH to basic. Basic means the boiler feed water. It's a boiler. It is called the feed water to the boiler. The feed water to the boiler, for the pH water treatment output is 6 or 5.9. It is increased to 9.2 or above 9 to make it more alkaline before feeding to the boiler. Why? Because the acidic water will have erosion effect inside the boiler, and it will damage the boiler tubes. So what they will do, they make it alkaline. They make it alkaline using hydrazine. So for high pressure boiler, we use hydrazine. Its formula of hydrazine is N2H4. N2H4. Everybody can note it also. Hydrazine. So before feeding to the boiler, this water, we inject hydrazine to the feed water to make the pH from 6 to 9, above 9, 9.2, 9.3. So this hydrazine has actually 4 functions. Hydrazine is a chemical. It increases the pH and it removes the oxygen from water, because if there is oxygen inside the water, the oxygen will cause pitting, corrosion, oxygen corrosion. It is called pitting corrosion. So this oxygen, hydrazine will remove all the oxygen from the feed water. And so first it will increase the pH. Second, it will remove the oxygen. It is called oxygen scavenger. Hydrazine is also called an oxygen scavenger to remove the oxygen in the feed water. And the third is it will produce ammonia. When it is heated up, hydrazine is heated up, it will produce ammonia. And this ammonia is actually helping to increase the pH. So an ammonia will be there in the water, with seawater, and this ammonia will automatically help to increase the pH, which will protect the boiler tubes. And the fourth one is it liberates nitrogen. Nitrogen, all you know, 79% of the air contains nitrogen, and nitrogen is theoretically chemically inert. It is an inert gas, chemically inert. So when nitrogen is produced, it will not have any adverse effect inside the boiler. So because nitrogen is chemically inert. So before feeding to the boiler, we inject hydrazine, as hydrazine solution will be there. So we increase, normally we inject using a pump, dosing pump to the boiler, and the hydrazine level inside the feed water is maintained around 0.2 to 0.3 ppm. ppm means parts per million. Parts per million is called ppm. It can also be called milligrams per liter. Milligrams per liter is equivalent to ppm, and it is called it's a unit of content of hydrazine. Not every material. So hydrazine inside the feed water, we keep 0.2 to 0.3 ppm. So excess. That means after removing the oxygen and all, the hydrazine value in the feed water is maintained around 0.2 to 0.3 ppm, milligrams per liter. So this will protect the boiler tubes. So normally what will happen? This hydrazine we inject to the feed water, and it is heated inside the boiler, and steam is produced, and the steam also there is superheated steam. The steam also will be alkaline. When we condense the steam, we check the pH, it will be around 9.1, 9.2 like this. It will protect the boiler. So this is one chemical used inside the boiler. The second chemical used inside the boiler is trisodium phosphate. Trisodium phosphate and disodium phosphate. It is called what you call TSP. TSP is trisodium phosphate, Na3PO4. That is trisodium phosphate. And disodium phosphate, Na2HPO4. That is disodium phosphate. So these both are mixed together in 5